For this video, we will cover how to complete X-linked pedigrees, and for our class, we will really only worry about recessive X-linked pedigrees. Let's start by talking about the items that we use to identify a pedigree as X-linked. Predominantly males affected, rarely any females affected. The trait may skip generations, and there is no father-to-son transmission. With that out of the way, let's take a look at a pedigree and go through some basic ways to complete it. Let's start by adding in all the knowns. Since this is an X-linked trait, we do need to keep track of the males and females in the pedigree. And we can now no longer use any letter to designate the alleles. We have to use X's and Y's as those pertain to the sex chromosomes. You can write these a couple different ways, but I tend to just use big and small X's. The Y is really not important in solving the pedigree, it is just added to all the males as they should have one. With that in mind, we now have 5 possible combinations of letters. Big X would be a full dominant female, which does not have the trait. Big X would be a heterozygous female. We also call this a carrier. A carrier is an individual that has the trait, can pass it on, but does not express it. We can also have a x, which is a female with the trait. Y big X, which is a male without the trait, and Y little x, which is a male that has the trait. Note that since males have either a big X or a little x, and generally do not have both, we can't have male carriers. This also explains why males are more likely to have X-linked disorders. They either have it, having the small x, or they don't, having the big X. Women are less likely to get it as they need 2 small x's in order to get the trait. Alrighty, that was a long explanation of how we have to use our letters, so let's actually get started with solving the pedigree. To start out, let's go ahead and give all the males, shaded and unshaded, a Y chromosome. Next, since we know that this is a recessive trait, let's give all the shaded male individuals a lowercase x since they have the trait. And all the unshaded male individuals get a big X since they do not have the trait. Once we have completed this, all the male individuals in the pedigree should be done, and normally we can complete all of them right off the bat with what is known. Next, we would look for any females that have the trait. These would all need to be little x in order to have the trait. So they're also completed just with our known information. Next, we can give all the unshaded females one big X since they have to have at least one to not express the trait. And now we can go ahead and ask the question, what is the second allele for the unshaded female individuals? Let's start with individual 1-2. This individual has to be heterozygous or big X little x. The justification here is individual 2-3. This individual received their Y chromosome from dad and has one small x since they have the trait. Since dad gave the Y, this individual would have to have gotten the small x from the mom or individual 1-2. Let's go ahead and skip individual 2-1 for now. So next is individual 2-5. This individual has to be heterozygous or have both a big X and a small x. The justification here is individual 3-5. He received his Y chromosome from the dad and has one small x that he would have had to have gotten from the mom in order to have the trait. Let's move on to individual 3-2. This individual has the same reasoning as the 2 above. They have a son that have the trait. The father donated the Y chromosome, so the mom had to have been the one that donated a small x for the son to be expressing the trait. Now we have individual 4-2. This individual would be a question mark as the second allele. The thing here is that we know that dad had to have donated an X allele, and since dad can only donate a big X, we can assume that that is the allele we accounted for when we added in our knowns. Now, in terms of what mom donated, since mom has both a big X and a small x, there's a 50% chance that she donated either. And we won't be able to justify either unless we get some offspring data later to help determine which was donated. Now, let's go ahead and go back to individual 2-1. Looking at this individual, it looks to be a question mark to start out with. The reasoning here is that neither parent is expressing the trait, so while we know that dad had to donate his big X, we can't know what mom donated, either the big or small x that she has. However, since we have solved the child of the individual, we can justify that the individual has to be heterozygous or big X little x. Since the child is heterozygous and dad could only give off a big X, the child would have had to have received a small x from the mom. Keeping these simple rules in mind should make you able to complete X-linked pedigrees without too much trouble, specifically the recessive ones. Always start by confirming the pedigree is in fact X-linked recessive. Then add your knowns to complete as much of the pedigree as possible. And then just ask, what is the second allele of all the unshaded female individuals? This concludes a video covering how to complete X-linked recessive pedigrees